Okay. Hi, hello everyone. Hi everyone. Welcome to the live session. Today I'm your Aditi ma'am, and today we are going to do sample paper, the official sample paper given by CBSE. How are you all doing? Who ate my samosa? Hemant, Ahad, Mikasa. How are you all, guys? Am I audible and visible properly? Good morning. Hi everyone. How are you all doing? How are you all doing? Can we start the live session? We are going to do the sample paper, and we know. Hi. Who ate my samosa? How are you? Oh, definitely missed you. We are going to do sample paper today, and we all know how important this is, right? Lots of questions can come, not directly I will say, but the pattern of the questions can be same, right? So let's start. Give me a thumbs up. Can we start? Hi Sachin, Krishna, how are you? Sorry, I had a little cold and cough. Okay, can we start? I'm great, samosa. Okay, let's start with the very first question. Kani is asking, can you teach how to find magnetic effects, direction and stuff? Yeah, sure, I can teach you. Let's just focus on sample paper for now, okay? And then I'll let you know. In the live session, I'll give you some time to solve the question. So, in that meantime, I'll teach you, okay? Ma'am, volume. Is my volume not okay? Let me know if the volume is not loud enough. Okay, can we start? Okay, we have thumbs ups. Okay, let's start with the very first question. The first question, it says, Arnav was making notes and he wrote down the following statements from his understanding of reflection from curved surfaces. Let me know. Let's see who can answer first. Okay, this is a big question, but read it very carefully. Okay, the first is concave mirrors can produce both real and virtual images depending on the position of the object. Okay, they are saying that concave mirror can produce both real as well as real and virtual images. Okay, what is the second part saying? Second part is saying convex mirrors produce real images regardless of the object position. Always, it is saying convex mirror always produces real images. Okay, third says in both concave and convex mirrors, the image location can be determined using the formula 1 by f equals to 1 by v plus 1 by u, where f is focal length, v is image distance and u is object distance. Choose from the following the correct option that lists the correct statement about reflection from curved surfaces. Oof. Bam. Okay. A, we have answers as A. Somebody was saying A, right? Hello Billa, how are you? Let me know what is the answer to this question. Everyone, I need each one of you to read this question carefully and answer correctly. Okay, let me know what is the answer to this particular question. Fast. Everyone. Okay, so let's see very carefully. So the first part says that concave mirror can produce both real and virtual images. Okay, that is true. We know concave mirror in first 5 cases it produces real and inverted images. Okay, but in 6th case it produces virtual images. So first option is correct, right? Then A, we have the answer as A. Okay, convex mirrors always produce real inverted images. Is that true or not? Convex mirror, when did convex mirror produced real images? In which case convex mirror produce real images? It doesn't. Convex mirror always produce virtual and direct images. It never produce real and inverted images. So second is not true. So whoever is saying A option needs to rethink. Okay, fine. Then in third they are saying for both concave and convex we can find the image distance by using the formula 1 by f equals to 1 by v plus 1 by u. 1 by u. Done? And so that is true. So actually the third option is correct. So what is the correct answer then? The correct answer will be option number D. The correct option is option number D. Everyone who was saying hi Raju Gamer, everyone who was saying option A, that is wrong. Okay, done, understood? This question done. Can we move to the next one? Yes, Sachin is saying C, that is true. Sachin, you are absolutely correct. Okay, let's move on to the next question. Oh, C, no, right, sorry, C, Sachin is not correct, my mistake, it is actually D, right, yeah, Billa and one more person said D, so its answer is actually D, okay, all your pre-boards are done, everyone, all your pre-boards are over, right, till now, nobody is having their pre-boards still going on, or practicals. Anyone still left with the practical exam? Okay, let me know. Let's until then look at the second question. It says, choose the correct option from the below which explains the reason for us to perceive the day sky as blue. The first is, as sunlight passes through the atmosphere, shorter wavelengths such as blue has shorter wavelengths, they are saying, are scattered more than other colors, right? Then the sky appears blue because all colors are scattered equally, but blue light is stronger and more visible to the human eye. Okay, the blue color of the sky is due to the longer wavelength like red and orange scattering more than shorter wavelength, making blue stand out. The atmosphere contains blue colored particles that give the sky its blue appearance. Yes ma'am, done. Okay, both completed. No, Hemant is saying no. Your pre-boards are still left or they are done. Okay, let me know the answer to this question. What is the real reason that the color of our sky is actually blue? Hemant is saying C. Okay, anyone else who wants to challenge Hemant? Hemant is saying that the blue color of the sky is due to longer wavelengths like red and orange scattering more than shorter wavelengths, making blue stand out more. Is that right? Hi, well, hello everyone, welcome to the live session. We are solving sample paper, the official sample paper given by CBSE, and we all know how important that is, so be careful and stop your chit chats for some time now. Okay, Ahad is saying A, Deepak is saying A, and who else? We have answer as C. Okay, let's see what the answer is. The answer is actually A. Very good, all of you. The answer is actually A because, देखो, see, in the C part, they are saying the blue color of the sky is due to longer wavelengths like red and orange scattering more. But red and orange does have longer wavelengths, but that does not mean they scatter more. That means they scatter less. On the other hand, blue color has shorter wavelength which scatters more. Blue has shorter wavelength which scatters more, and hence because of lots of scattering of the blue color, we appear that the sky is blue. Okay? Okay, Jai Hind Sarma ji, how are you? Blue has the shortest wavelength, so it scatters the most. Very good, Deepak. Okay, let's move on to the next. We have third question, which is assertion. Reason question. Assertion says a point object. Okay, look at this very carefully. You might need pen and paper for this. A point object is placed at a distance of 26 centimeter from a convex mirror. So we are given with convex mirror, and we are given that an object is placed at a distance of 26 meters from the mirror, right? So you will be minus 26, right? Then focal length is 26 centimeter. Okay, this is centimeter. Now focal length is also 26 centimeter. Tell me what is the sign of focal length of convex mirror? What is the sign of focal length of convex mirror? Hi Bhagwati, how are you? Let me know what is the sign of focal length of a convex mirror. Then the actual assertion is a point object is placed at a distance of 26 centimeter from a convex mirror of focal length 26 centimeter. Okay, the image will not form at infinity. What is the focal length? Yes, it is positive. Billa, Sarmaji, everyone is saying positive. We can agree to that. So this is positive. So focal length is positive 26 centimeter. Now they are saying that object and focal length is same. That means my object is placed at focus. My object is placed at focus, right? So where will the image be formed? But it is a case of convex mirror, remember. So they are saying the image will not form at infinity. So is the assertion correct? C. We have lots of answers as C. Very good, very good. Okay, C. Right. So when object is at focus, we know the image forms at infinity. But that is for concave mirror. For convex mirror, we know that the image is always between pole and focus. Done? Yes, very good. Everyone is giving C answers. Let's see. So assertion is, it's actually true, right? They are saying that the image will not form at infinity, which is true. Right? Then what is the reason? For above given statement, the equation 1 by f equals to 1 by v plus 1 by u give v equals to infinity. Now let us put our values. So 1 by f equals to 1 by v plus 1 by u. So 1 by f is 1 by 26 equals to 1 by v minus 1 by 26, right? Because my u is negative, right? So 1 by v from here will be what? 1 by v will be 1 by 26 plus 1 by 26. So there is no negative sign, right? There is no negative sign. It cannot get cancelled. It is not coming as infinity. So v is not infinity. So assertion is correct, but reason is false, right? So we have the answer as C, which was given correct by most of my students. Very good. Okay, let's move on to the next question. We have an image, right? The above image shows the formation of an image with an optical instrument. We are given a normal optical instrument. Then we are asked certain questions. First is identify the type of optical instrument in the image. Let me know which is the optical image that is used in the optical instrument that is used in this image. Let me know fast everyone. What is the optical instrument that is being used in this particular image? Ma'am, it's a concave mirror. Okay, Deepak, let's think again a little bit. Think again. Concave lens, we have the answer as concave lens. Concave lens, concave lens, concave mirror. Concave mirror, okay. Concave lens. Hi. Concave, okay, let's see. See, for the very first part you have to see is that this, whatever this instrument is, right? Whatever this instrument is, we can see real rays crossing through this instrument, right? The real ray is actually passing this instrument. So it cannot be mirror. It cannot be mirror, right? It cannot be a mirror. Correct, because in mirror we only see reflection, not refraction, and here we see that the path of ray is getting deflected and it is passing through that optical instrument, right? Image will be virtual, erect and diminished. Yes, of course. Let's see what is the image. So for the first part it is not a mirror, so it is a lens. But which lens is that? Which lens is that? See, the ray is going and it is not, first point, it is not getting converged. First point, it is not converging, right? It is not converging. So it is a diverging lens. It is a diverging lens. And which lens is diverging lens? Ma'am, that is my concave lens. That is concave lens, which is a diverging lens. One more thing that you can see from this is that the image is being made on the same side of the object, right? This is the object, this is the image. So image and object are on the same side. That only happens in concave lens. So everyone was true who said concave lens. Now let me know the answer to the second question. What type of image is formed in this case? What type of image, everyone, will be formed in this case? Let me know. What kind of image is being formed in this case? You guys have exam in literally 15-16 days, eh? And you are here chit-chatting in the live chat. It's fine, your wish. Yes, we have the answer as virtual, erect and diminished. We have the answer as, okay, that is great, that is good. We know just from reading concave lens, we can directly answer it is virtual, it is erect and it is diminished. It is diminished, right? Okay, good. Everyone, great. Now, let me know the answer to the third question, third part, that is, based on the measurements given in the image, calculate the focal length of the instrument. Can you find this? I need a PDF. Yes. Go follow the, there is a link in the description. Go join that WhatsApp channel and we'll help you provide the PDF, okay? Yeah, yes. Yagna Patel. Okay. We'll see about the PDF. There is a link in the description. Go join that WhatsApp channel and we'll see about the PDF, okay? Okay, we have the answer. The focal length will be minus 20 centimeter. Okay, let's see. See, from this image, we can clearly see that the object is at 20 centimeter. Right? So, U is equal to minus 20 centimeter. Done. Then we have V. Now, V is also on the same side of image on the left hand side, and so V is a sign will also be negative. So, V is minus 10 centimeter. Done. Now, ma'am, we can directly use lens formula, right? We can use lens formula directly to calculate the focal length. 1 by F equals to 1 by V minus 1 by U. 1 by V is minus 1 by 10 minus U is minus 20. So, that will be minus 20, right? So, this will become what? minus 1 by 10 plus 1 by 20, right? Negative, negative, plus, and we can just take the LCM as 20. This will be minus 2 plus 1 will be minus 1 by 20, and this is my 1 by focal length. So focal length is minus 20 centimeters. Sharma Ji was correct. Focal length is minus 20 centimeter. Very good. Okay, let's move on to the next question. The next question says, find out the following in the electric circuit given in the figure. See, I asked you to get your pen and paper and sit down, because we are going to solve the whole question of physics, question paper of physics, right? So find out the following in the electric circuit given in the figure. The first thing we have to find is effective resistance of 2 ohm resistors in the combination. We have to find the effective resistance of the resistors where R1 is equal to 8 ohm and R2 is always also equal to 8 ohm. Let me know which combination is this. Which combination is this? Parallel or series? 8 ohm are connected in parallel or are connected in series? Hi Prince. Yeah, Deepak, I'll ask them. 4 ohm, we have answer as 4 ohm from Sharma Ji, from Amit. Okay. Parallel, very good. Sharma Ji said the answer as parallel, 4 ohm. Okay, let's solve the question. Let's see if you guys are correct or not. My students who are working hard, see, both of these are in parallel connection. Very good. Both of 8 ohms are parallelly connected to each other. So for parallel connection resistor, we have the formula 1 by R1 plus 1 by R2. Great. Now R1 is 1 by 8. This will be 1 by 8 plus 1 by 8. If you take the LCM, this will be 1 plus 1. That will be 2 by 8, which will be 1 by 4. So RP will be 4 ohm. Very good. Everyone, Amit, Sharma Ji, everyone. 4 ohm was the correct answer. Okay, we have the current as 2 ampere and 1 ampere. Let's see who is correct. Let's solve the question and see if Amit is correct or Deepak is correct. Sharma Ji, what do you say? Who is correct, Deepak or Amit? Now, second is current flowing just through the 4 ohm resistor. Just through this resistor. Now, see. What we need to do whenever we get a circuit like this, we will calculate the effective resistance, right? So we calculated the effective resistance of this part, which is 4 ohm, correct? See, we calculated the effective resistance of the 8 ohm part, right? So this is 4 ohm now, and the total circuit is 4 ohm, and here we had a voltage. This is the whole circuit, right? If you leave out ammeters and all that stuff, it will be this. Basically, this is the whole circuit, right? Now, these two are in series. So, the effective resistance of the whole circuit will be 4 plus 4, that will be 8 ohm, correct? Now, V equals to 8 volt. So, we have to find current. So, we can use Om Baba, right? Om Baba gave us a formula. Which formula? Om Baba formula we call it. We call it Om Baba formula, which is V equals to IR. Now V is given as 8 volt. I we have to find, resistance is also 8. So current will be 8 divided by 8. That is 1 ampere, my friend. That is 1 ampere. So current is 1 ampere. Now since it is in series, so if the current that is flowing through the whole circuit will be flowing through this resistance as well, right? Right, everyone, correct. Okay, let's move on to the next question. Now before that, go like this session. Very good, very good. Go. Like this session, subscribe the channel. We are going to bring so many lives for you. We are solving sample papers. We will be bringing more papers as well, so that you have complete revision of how to give the paper. Okay? Right? Okay. Next question we have, again, we will require a pen and a paper. Okay? Everyone who is making a mistake, it is completely fine. We are here to revise. Okay? Everyone who gets the answer wrong, it's completely fine. We are here to practice, and in the practice we are okay. It's okay to make mistakes. Right? Now go take your pen and paper. It is just important to revise properly, to give your 100%. Okay? So study the circuit and find out current in 12 ohm resistor. We have to find current in this 12 ohm resistor. Let me know what will be the current. There is too much poems, shairi we call it, in our live chat, and that is what CBSE will ask. Where did you give your heart? We have the answers 12 ohm and 0.25 ampere. Oh, we have another answer, that is 0.5 ampere from Mahi. Mahi is saying 0.5 ampere. Okay, let's see who of you is correct. Right? See, this is a series circuit. Correct? What circuit is this? It's a series circuit. So the first point, whenever we need to find the current in a particular resistor, we will find the current in the whole resistor, whole circuit first. So the first step is to find the equivalent resistance of the circuit. Right? Equivalent resistance of the circuit. So these are in parallel. Let's say this is 1, this is 2, and this is 3. Okay? So R1 and R2 are in parallel. So 1 by R12 will be 1 by R1 plus 1 by R2. Right? So this will be 1 by 24 plus 1 by 24. That will be 2 by 24. Correct? And so R12, if you cut this will be 1 by 12, R will be 12 ohm. Until here everyone is clear, right? Now this whole is 12. So 12 plus 12 will be, so the total resistance will be R12 plus R3, right? That is 12 plus 12, that will be 24 ohm. Correct? Anyone has any doubt? 0.25, 1 by 4. Okay. Zero difference in A1 and A2. Okay, we have lots of answers. Okay, done till here. Now the whole resistance we have as 24 ohm. Right? And what is the voltage? The voltage is 6 volt. The voltage is 6 volt. And we have to find current. Again we'll use Ohm Baba's law, right? Which is V equals to IR. V is 6 volt. What is this? This is 6 volt. Okay? We have to find I, and R is 24. So I will be 6 divided by 24. This will be 1 by 4. So I is 0.25 ampere. Everyone who said 0.25 ampere, very good, very good. Right, great. Very good. Okay, why we calculated complete resistance? Because this 12 ohm is actually in series, right? And in series, we know in series current does not divide. Right? That is why the first step is to calculate equivalent resistance. Okay? Okay, okay, very good. Then we have the second question, difference in the readings of emitter A1 and A2. What will be the difference in the readings of A1 and A2? Let me know. Thank you, Sharma ji. 24 ohm, Amit is saying 24 ohm is the answer. This one, 0.25 ampere, very good. Okay, okay. Now let me know the second question, second answer, difference in the readings of emitter A1 and A2. See, emitter A1 is connected here and A2 is connected here. What is the same, okay. Zero difference, same. Very good, everyone. Chetna is also saying 0.25. Chetan or it's Chetna? Okay, very good. Different, zero difference. Very good. See, again, both emitter A1 and A2 are in series, right? Emitter A1 and A2. See, this is kind of my circuit. This is A1. Again, we have a resistance and A2. Done. Now, if current does not divide in series, this is the main point. It does not divides in series. Right? So, A1 and A2 are in series. A1 and A2 are clearly in series. That means the difference between the readings of A1 and A2 will be 0. Right? Very good. Everyone, very good. Boy, ma'am. Okay, Chetan then. Okay, very good. Let's move on to the next question. We have a question from the chapter Human Eye. Read it carefully. Read the question very carefully. Right? See, let's read the question. The above image shows a corrective measure for a particular defect of vision. Okay? Identify the defect of vision and state what kind of lens is used to correct this deficiency. Let me know which kind of defect is there in this image. Defect in the image. Defect depicted in the image, not the defect in the image. What is the defect depicted in this image? Sharma ji is saying hypermetropia. Okay. Hypermetropia and convex. Okay. Okay, let's see how to do it. Okay. Hypermetropia and convex. Very good, Sharma ji. So let's see how we came to that conclusion that it is hypermetropia. Okay. See, we have two ways. Okay. Let's see two ways. First is, you can clearly see that this lens which is depicted is convex lens. It is clearly visible, right? So convex lens is used to correct a defect, right? Then which defect is that? That is hypermetropia. Convex lens is used to correct hypermetropia. Very good. Okay. Now the second part where we can see which defect is this, that okay, you cannot. I thought the image will be meeting somewhere else, but also you can see from this part that the near point has shifted, right? The near point has shifted. So you can see clearly that the near point of eye is shifted. Eye is shifted, and if near point shifts, then that defect is called hypermetropia. Hypermetropia. Understood? Now the second is state what kind of lens that we can clearly see. If you came to this conclusion first, you know to correct hypermetropia, we use convex lens, right? To correct hypermetropia, we use convex lens. Done. And then again you can clearly see that this lens is clearly convex lens, which we saw first as well. Done. Okay. Right? Okay, let's see what is the next. Draw and label a ray diagram that shows the defect of vision in the above case before correction. So we need to show hypermetropia defect, right? Hypermetropia defect. We need to draw its diagram. Let's draw the diagram, right? Very easy. You'll just make a human eye, right? You'll just make an eye fairly good. Now this is my eye lens, right? What is happening? In the hypermetropia, the image is formed behind or front of the retina. Let me know. In hypermetropia, where the image is formed? Behind the retina or in front of the retina? Ma'am, what is astigmatism? Astigmatism is a kind of defect where you are not able to see the image, the object correctly because of the shape of your eye. Because the shape of your eye gets distorted. Okay? Behind, Sharmaji is saying behind. Very good. So, in hypermetropia, image gets formed behind the retina. So, that is what you have to show, right? Behind the retina. That is only what you have to show. Now, do use scale and your pencil for that. Okay? Let us make, this is the rays coming parallel. Okay, no. The rays should be coming from a near point, right? In case of hypermetropia, we have a near point. So, what will happen? Rays are coming from the near point. They are coming from the near point, and instead of meeting on the retina, they are meeting behind the retina. Done? And this is where my image is being formed, and this is where the object was. Done? Everyone understood this diagram? Right? Okay, very good. Yeah, I'm really my throat is a bit not good, so you guys stop doing that chit chat. And it is like, what are you even talking about? Why are you here to talk about all this stuff? I am a physics teacher. I don't know what tubectomy is. Okay. Let's move on to the next question. See, this is a very important session because this is a sample paper we are solving, and it is very important because a lot of similar questions can directly come into your exam. So if you want to score good, I want you to focus on the session. Okay, right. Let's move on to the question. A student needs to make a 0.12 ohm resistor. Okay, we have a resistance as 0.12 ohm. Correct. She has some copper wire of 0.80 mm diameter. Now, diameter is also given 0.80 mm. Make sure you are looking at the units very correctly. Okay. The resistivity of the copper wire is also given. So, the resistivity is 1.8 into 10 raised to power minus 8 ohm meter. Right. Determine the cross-sectional area of the wire. Now, who can tell me what is the cross-sectional area of this wire? What will be the cross-sectional area of this wire? Let me know fast. Hi, princess. Good morning. How are you? We are solving this question here. We are given with resistance, we are given with diameter, and we are given with resistors. So, first what we have to see, what is the cross-sectional area of the wire? Let me just ask my team to block you guys. Wait a minute, it is too much. Wait. How? I can't let you go like this. Okay. Now I'm not reading your comments at all. Let's just solve the question. A student needs to make 0.12 ohm resistors. Okay. She has some copper wire of 0.80 mm diameter. Resistivity of the copper wire is also given. First we have to calculate determine the cross-sectional area of the wire. So we have to calculate the area of the wire. Now very easily it is given by pi r square, right? Pi r square, we need to have r for that, okay? We need to have r for that. So from diameter, let's just calculate r. That will be 0.8 divided by 2, right? That will be 0.4 mm. Now be very careful. This resistivity is in meters and resistance is also in ohm. But the diameter is in mm, right? So we have to convert it into meters first. That will be 0.4 into 10 raised to power minus 3 meters. Done. So this is my new radius, that is in meters. Okay. Okay, see, now we can just put the values here. It is 3.14 into r is 0.4 square into 10 raised to power minus 3 square, 10 raised to power minus 3 square. Done. That will be 3.14 into 0.16 into 10 raised to power minus 6. 0.16, yes. Can you solve this? Very easy calculation, right? Okay, let's move on to the next part. This is a very easy calculation. I will not be doing it. If you are, let me know in the live chat. Okay? Okay, princess. Okay, next is calculate the length of the wire required for the 0.12 ohm resistor. Now see very carefully. Yeah, okay. Hi Naveen, very welcome to the session. Hi. Okay, let's see, we have area, right? We have resistance, we have resistivity as well. Can we clearly calculate length? R equals to rho L by A, right? Rho is what? Rho is 1.8, correct? 1.8 10 raised to power minus 8. 1.8 into 10 raised to power minus 8 into length we have to find, right? Area of cross section we got 3.14 into 0.16. 3.14 into 0.16, and we have resistance as 0.12 ohm. We have resistance as 0.12 ohm. So can you calculate this whole calculation? 0.12 into 3.14 into 0.16 divide by 1.8 into 10 raised to power minus 8. Done. If the diameter is in centimeter, Sharma ji, then you will have to multiply with 10 raised to power minus 2. Okay? 10 raised to power minus 2. Done? I cannot filter your comments. It's fine. It's fine. I'm reading your comments. Whoever is actually asking the questions, I'm replying. Okay? Done. Now let me tell you a very simple, a very basic trick. If you don't have time in your exam, what you need to do, just multiply. If I put this point here, there will be one more 0. Very carefully look at this. 0.12 into 3.14 into 0.16, right? Divide by. If I write it as 0.18, then there will be one more. There will be 10 raised to power minus 1 here, right? There will be 10 raised to power minus 1 here, correct? So this will become 10 raised to power minus 9. Now be very careful. You can directly cut these two values. Okay, it's fine. You will write the answer as approximation anyways. So it's fine, Hemant. It's fine. It's fine. You just focus on studies. Okay. So you can now clearly multiply 3.14 into 0.12 and 10 raised to power minus 9. If we take this above, it will be 10 raised to power 9. This is the value of length. Can you solve it? I'll tell you the exact answer. Let me solve it. It's fine. Just be very careful. It's fine if you write it like this and solve it. You don't need to hurry in the exam. Okay. This will be 8, 2, 6 and 3, 1, 4, which will be 8, 6, 7, 3. That will simply be 3, 7, 6, 8 and 1, 2, 3, 4. The point will be here. So the option is, the answer is 0.3768 into 10 raised to power 9 meters, right? The answer is, length is 0.38 approximation into 10 raised to power 9 meters. Done? Any doubt? Anyone has any doubt? It's fine. Okay, okay, Sharma ji. It's my birthday today. Santosh is saying happy birthday, Santosh. Okay, let's move on to the next question. Okay, next question we have from the chapter magnetic effects of electric current. Magnetic effects. Read it very carefully. Read it very, very carefully. Magnetic field lines are shown in the given diagram. A student makes a statement that the magnetic field at X is stronger than Y. They are saying that magnetic field at X is stronger than magnetic field at Y. Explain with the reason if the student's claim is correct or not. So let me know if he is correct or not. Yeah, if you don't have time, Sharma ji, if you don't have time, you can anyway 0.16, 0.18, you can directly cut them. It's fine. X is stronger because lines are close. Correct. Very good. Very good. That is correct. We can clearly see here, right, that the magnetic field lines are getting accumulated. And they are more. Here they are far away. So the student's claim is definitely correct. Very good. Done. Next, this is my first part. Second part, I also redraw the diagram and make the direction of magnetic field lines. I am redrawing the diagram. Let me know what will be the direction of magnetic field lines. In the chat, everyone, let me know the direction of magnetic field lines outside as well as inside. Okay? This is my magnet. And let me say this is North Pole, this is South Pole. So direction, so magnetic field lines will be something like this, that we know. But what will be the direction? What will be the direction? Be very careful not to touch these magnetic field lines with each other when you are drawing them in the exam. Okay? What will be the direction of magnetic field lines? From north to south outside and south to north inside. Very good, Sharma ji. Devdas finally has some knowledge. Okay. From north to south outside, south to north inside. Very good. North to south outside, south to north inside. North to south outside, south to north inside. Very good. Very good. Inside, south to north. Shagun is saying. Very good, Shagun. Okay. Next, we have, it's a very big question. It's a case-based question. Do not worry. Okay, do not worry about it. We will read the same question line by line very carefully. Okay, the first 4 lines are anyways a story, so just read it very carefully. It's fine. The above image is that of a DSLR camera which are used to take high resolution photographs by professional photographers. Is there anything technical in this? No. The second image of the above 2 is a schematic diagram of how an image is formed in the sensor of the camera. Okay, done. Based on your understanding of the lenses, answer the following questions. Just go with one question at a time. A part is saying what type of lens is used in DSLR camera shown in the image. There is a lens that is shown in the image. What kind of lens is that? What kind of lens is that? Convex lens, very good, very good. Each one of you have a different place in hell. It's your actions. I didn't do anything. Shagun is saying convex, very good, very good. Okay, we can clearly see that this lens is a convex lens. If you cannot see, there is an enlarged image. We know that this is definitely a convex lens. We know by now that this type of lens is called convex lens. Very good. Okay, A part is done. B part, what type of image is formed on the sensor? Okay. Now look at this image and look at this object carefully and tell me what kind of image is formed on the sensor of this lens, on the sensor of this camera. Real and inverted. Sharma ji is saying real and inverted. Okay. We have the answer as real and inverted. Very good. Okay, chalo. Next, we have what kind of image is formed? We have the answers as real and inverted, and that is true. See, the object, the tree here was erect. It was erect, right? But here you can see that the tree is opposite. It is inverted, right? So, the B part is real and inverted. Very good. Everyone who is answering, I am so proud of you to not get distracted. Okay, let's go to the option number, answer number C, question number C. Okay, a photographer is using DSLR camera with a lens of focal length 50 mm. Okay, as we read, we write. Okay, so C part we have a focal length of the camera that is 50 mm. Right? Next, to take a close-up photograph of a small object, the lens projects an image onto the camera sensor that is located 60 mm. See, the image is being made 60 mm from the lens. So, we will be 60 mm behind the lens. That means positive, right? Now, it's a convex lens. Focal length of convex lens is what? Focal length of convex lens is positive. Very good. Next, Calculate the object distance, that is distance between the object and the lens. We have to calculate object distance, that is u. Can you tell me what will be the value of u? Bas, if you would have worked this hard for studying, that will be a different game. Okay, let me know what is the value of u in this case. Anyone has any answers? Let me know, let me know. What will be the value of u? Now, since you all are here, came with different IDs, go like this session. Huh? Since you are here, be of any use. Yes, I am waiting. Okay, okay. Let me know what will be the value of u. The value of u, that is my object distance. We have to find object distance, right? Let's see how to find the object distance. See, f and v. Yes, Sharma ji, you can answer. I'm waiting. Okay, let us just solve it alongside, right? I can definitely use lens formula. Correct? I can definitely use lens formula. Correct? Lens formula is 1 by f equals to 1 by v minus 1 by u. Right? Now, f is 50 mm. Since everything is mm, see, have they asked you to calculate the object distance in mm or centimeter or meter? No. Right? So, you can calculate in mm as well. 1 by 50 equals to 1 by v minus of, now see, u is not given to us, we have to calculate u. Okay, we have to calculate v is given as 1 by 60 minus 1 by u. Done? We have the answer as Aditi is saying 300, Kavita was saying 30, and I saw one more answer, I guess. Okay, let's see, let's try to solve this. 1 by 50 equals to 1 by 60 minus 1 by u. So, minus 1 by u will be on this side. 1 by 50 minus 1 by 60. Done? Easy. For this, can I take the LCM as 300? Right? So, 50 into 6 will be 300, right? 50 into 6 minus 60 into 5. 60 into 5 will be again 300. 60 into 5 will be again 300. Then this will be the LCM minus 1 by u. This will be 1 by 300 and that is minus 1 by u. So, u will be minus 300. Make sure you write mm here because we have calculated in mm only. Minus 300, 300. Very good everyone. Sharma ji, Aditi. Very good. Okay. Then we have the next part. Let's see what is the D part. C part is done. Let's see go to the D part. A photographer is using a DSLR camera. See, they are just trying to make you read more and more sentences. They are trying to trick you. But you are not getting tricked. We just have to see V, U and F. Only 3. Okay? To take a picture of a flower. The flower is positioned 150 mm away from the camera lens. Now we are given the distance of flower itself. So that will be my object. Right? That will be my object. So U is given as 150 mm and U is always negative. Then the flower is positioned 150 mm away from the camera. The actual height of the flower is 80 mm. height of flower, that means height of object is given as 80 mm, right? And what else is given? And the image height formed on the camera sensor is measured to be 20 mm. So height of image is given to be as 20 mm. Right? We need to calculate the focal length of the camera lens. We need to calculate the focal length of the camera lens. Let me know. 1 by u mean plus 300 mm. It will be plus 300 mm. Let's see. Did we do any mistake? It should be plus. 1 by u mean, no, u will always be negative, Aditi. U, see, listen, u is always negative, whatever the case, concave lens, convex lens, for mirrors, u is always negative, so you can't be positive, right? Okay, let me know the answer to this question. Can you calculate the focal length of the camera lens? Can you find the focal length of the camera lens from this given information? Right? Let's see how to do that. Okay, let's see how. Okay, we have the answer as 37.5. Yeah, okay, Aditi, okay. Let's see how to calculate this, right? See, we have height of image and height of object, and we need to calculate focal length. So how will you first think about it? Let's talk about that, okay? So see, you have height of image and height of object. From here, can you calculate magnification, right? After calculating magnification, you can calculate V, right? And from that, you have U, you have V, you can calculate focal length, correct? Understood? Okay, let's see how to do it. So magnification of a lens is V by U, and it is height of image by height of object, right? So V is not given, we have to find. U is minus 150 mm, right? Height of image is 20 mm, height of object is 80 mm. Just make sure all the distances, all the heights are of same units, right? So this cancels out, this will be 4, right? So V is minus 150 divided by 4, and if you solve it, this will be 3 and 7.5. So V will be minus 37.5. It is coming as minus, right? I saw an answer 37.5, but it is minus 37.5. Correct? Anyways, it's a convex lens. For convex lens, the image is always virtual and erect. That means on the same side of the lens. So it will be minus 37.5. Done? Okay. Next, we need to calculate. We have V, right? And we have U. We can easily calculate the focal length. We have answers as 30, 30, 30. Sharma ji is saying wrong, not minus. Why not minus? Where? Which step is wrong? Let me know. See. Oh, it's a convex lens. Right. Understood. But what is wrong here? Okay, height of image, right? Height of image will also be negative. Yes. Height of image will also be negative. Correct. Who? Sharma ji. Sharma ji is definitely correct. Very good. So this is negative. No. Minus 20. This will be minus 20, and this minus and this minus will get cancelled. So we will be positive. Right. Very good. Yes, Hemant, if you have something good to say, I also want to say you something. There is a saying that if you don't have something good to say, don't say it at all. So now you have to decide. Okay, we have V. So 1 by F equals to 1 by V minus 1 by U, right? V is 37.5, so 1 by 37.5 minus U is 1 by minus 150, right? And this is 1 by F. So 1 by F will be 10 by 375 plus 1 by 150. What did you take the LCM of this, Sharma ji? Answer is F equals to 30. Minus 50 is F. Okay, we have two different answers of F. So let me know what each of you took the LCM for this, because that is a very important point. But let me know. So you let me know what do you take the LCM. LCM 150. Okay. How did you take the LCM? Is 150. Okay, 150 लिया है. That means you didn't this point you still took, right? Okay, that is correct as well. 37.5 plus, right? Then if you took 150 LCM, 37.5 will be what? It will be 4, right? 37.5 into 4, 0, 2, 28, 0, 3, yes, okay, correct, very good. So this is 4 plus 1, that will be 5 by 150. Aditi, you want to tell us what LCM did you took? Or if we are doing right or not? Yes, yes. Saurav Kumar, yes. 37.5 multiplied by 4 is 150. Okay. Shivam is saying 45. 45 by what? Okay, you cut 10 by 375 by 5. That will be 2 by 75, right? Then okay, it's fine. You understood, right? By this case, it is understood. Okay, even if you take 75 and 150 can be taken as the LCM, right? So 2 into 2 will be 4 plus 1, 5 by 150. That is again the same. Yes, 30 will be the answer. Very good, all of you. You are great in calculation as well. Oh, where should I write? F equals to 30 centimeters. Very good. Right? However you do the calculation, it's fine. Just make sure you are doing it the right way and slowly. It's fine. Okay, okay, Sharma ji. All the best. Okay. Let's move on to the next question. 12th question we have. Zarina worked as an apprentice in a factory where flashlights and solar cookers are made. She learned to make the circuits, the design of the light bulbs, light concentrators of the solar cookers as well. All this is just a story to trick you. Nothing else. Okay? Then she learned the uses of lenses in making all those tools. Based on your understanding of lenses, answer the following questions. Question number A. What kind of lenses are used in the flashlight and light concentrator of the solar cooker? Let me know what kind of lenses we are using in flashlight or solar cookers. Virtual board exam. Okay, let me know the answers. What kind of lenses are we using in solar cooker as well as flashlights? Okay. Let's real hacker. Okay, I thought you are writing real and inverted image or something like that. Okay. Good morning, Samarth. How are you? Okay, let's solve the question. Okay, Samarth, tell me, what kind of lenses do we use in flashlights or solar cookers? What kind of lenses do we use in flashlights or solar cookers? See, in flashlights, what do we need? In flashlights, we need the light to diverge, to go to certain places, right? Okay, so in flashlights, we need a diverging lens. Right? And in solar cooker, what do we need in solar cooker? In solar cooker, we need to gather all the light and concentrate it at a particular surface or a place. Yes, Samarth is saying concave. Concave for what? Concave for what? Okay, for solar cooker, we need converging lens. Converging lenses. We need converging lens. For flashlight, we need diverging lens. Now answer me which lens is diverging and which is converging. You had used V equals to 37.5 for the calculation. So my answer comes out to be this. V equals to 37.5. V is 37, minus 37 point. Okay. Okay, maybe that's on me. You can put that on me. It's fine. You were correct. Okay? Okay, it's fine. कितने साल हो गए पढ़ते हुए? Me? From how many years am I studying or am I teaching? Sorry. Okay, first let me know the answer to this question, which is a diverging mirror and which is a converging mirror. You just said concave. Okay, it's fine, guys. It's fine. Just tell me, it is a concave lens or a convex lens? It's been on this platform. It has been 4-5 months, I guess. Okay, so diverging lens will be, it is concave lens. And converging lens we have is convex lens, right? Because convex lens gathers all the rays. Hi Shivam, hello. Okay, Samarth, you are again saying concave. Okay, so A part is done. Let's move on to the B part. B part, we have give reasons for your choices. We have given the reason. The first is flashlights, because in flashlights we need the rays to diverge, and for diverging lens we use concave lens. For solar cooker we need converging lens. We need all the rays, we need to gather all the rays and converge it at one point, that is convex lens. Done, everyone? Array, you study here, okay? Everyone focus on the question I am teaching, not the channel I am teaching on. Just focus on what am I teaching, what are the questions I am teaching, okay? Next, move on. And if you don't want to teach, it's fine, you can leave the class. Next is question number C, an object is placed 40 centimeter away from a lens which is normally used in solar cooker. Okay, now what lens did we used in solar cooker? We used convex lens, and they are saying an object is placed 40 centimeter away from the convex lens. So we are using convex lens, right? We are using convex lens and U is 40 centimeter. Correct? An object is placed 40 centimeter and U is always negative. Correct? Then we have away from a lens which is normally used in solar cooker. In solar cooker we use convex lens. The image formed is twice the size of the object. Now we are given that the image formed is twice the size of the object. So M is 2. Correct? M is 2. And we have to calculate the focal length of the lens. We have to calculate focal length of the lens. Correct? We have to calculate focal length of the lens. Now if I have magnification, can I easily calculate V because I have U as well? But magnification is also -2 in case of convex lens. Right? Done? Okay. Next we have magnification is V by U for a lens. Right? Now V is, we have to find U is -40 centimeter and magnification is -2. So this minus gets cancelled. V equals to 8 centimeter. So V comes out to be 8 centimeter. Done? Oh, it is 40. Sorry. V will be 80 centimeter. V will be 80 centimeter. Anyone has any doubt till here? Okay? Thank you. Okay, it's fine. You study. Your boards are very near and this won't get you any marks. And if you have studied, do not let other people get distracted. Okay. Then D option, we have an object is placed 20 centimeter in front of a lens which is used in flashlight. Okay, see now in flashlights which kind of lenses we used? We used concave lens, right? So in flashlight we used concave lens. In flashlight we are using concave lens, right? Concave lens. Now what is the focal length of the concave lens? The concave lens is, the focal length of the concave lens is always negative, right? And how much the focal length was given? The focal length was 20 centimeter. No. The object was placed at 20 centimeter. The image is formed at 10 centimeter away from the lens on the same side as that of the object. So U and V both will have negative signs, right? We have to find the focal length. Okay, let's see. So U is -20 centimeter, right? And V is -10 centimeter. Correct? We just have to find the focal length. Correct? So we can directly use mirror formula, 1 by V minus 1 by U. So 1 by V is -1 by 10 minus U is -1 by 20, right? And 1 by F. Correct? So this is -1 by 10 plus 1 by 20. And this will come out to be, the LCM will be 20 minus 2 plus 1. This is 1 by F. So F will simply be, this 1 by F is -1 by 20, right? So F is -20 centimeters. Okay, let's move on to the next question. We have the next question as, the arrangement of resistors shown in the above figure is connected to a battery. Okay, the power dissipation in the 100 ohm resistor. The 100 ohm resistor has a power of 81 watt. The 100 ohm resistor has a power of 81 watt. Aditi is saying F is minus 20. Yes, F was minus 20. Very good, Aditi. Okay, let's move on to the next question. We have the arrangement of resistors, and in this arrangement for the 100 ohm resistor, power is 81 watt, right? Let me write power is 81 watt. Power dissipation in the 100 ohm resistor. So, and resistor is 100 ohm. Right? The current in the circuit, we have to calculate the current in the circuit. So, if I calculate the current in 100 ohm resistor, current in 100 ohm resistor will be equal to the current in the whole circuit, right? Because in series, current does not divide. Okay, so we have I into 100 will be I equal to the current in the whole circuit. So I have this. What is the formula of power, resistance and current? Which will be the formula? What will be the formula relating power, current and resistor? That is very simple. P equals to I square into R. Done. P is 81 and it's in watt, so it's true units. I square and R is 100, right? From here you can easily calculate I square. 81 divided by 100. Okay, so I square is 81 divided by 100. If I have to calculate I, this will be the square root of 81 divided by 100. And this is very simple. I is 81 is the square root of 81 is the square of 9, right? So the square root of 81 will be 9 and the square root of 10 will be 100 will be 10. So I will be 0.9 ampere. Great. Done. Any doubt? Hi Naman. Okay, so we have calculated I. The first part is done. Second part, the reading in the voltmeter V2. In V2, this is V2. We have to calculate the reading in this particular voltmeter. What will be this? This is something, the kind of circuit we have, right? And this is V2, correct? This is 25. This is 25. And we know, we just calculated the current. The current was 0.9 ampere. But in here, the current will divide. So what will we do? So the first part we always do is to calculate R equivalent. That will be 1 by Rp equals to 1 by R1 plus 1 by R2, right? Now 25 is R1, 25 is R2. So that will be 1 by 25 plus 1 by 25. This is 1 by Rp, right? So 1 by Rp will be 25 and this will be 1 plus 1, 2 by 25. So Rp will be 25 divided by 2 and that will be 12.5 ohm. Right? So this circuit becomes 12.5 into V, and this is the V2, right? And now in this the total current will be going, that will be 0.9 ampere. So we will be using again Ohm's law. V is simply given as V we have to find, right? So V2, the current is 0.9 and my resistance is 12.5, right? So what will be this? 945, 4 above, that will be 18, 22, 2 and this will be 11.24, right? 11.24 volt. So V2 comes out to be 11.24. Done? everyone, the current in the circuit is 0.9 ampere, Hemant. Okay, Hemant, very good, very good. The reading is 11.25 ampere. 11.25. Oh, why did I write 4? Yeah, 11.25 ampere. 25 volt, sorry, volt. So voltage will be 11.25 volt. Very good, very good. Okay, let's see what is V1. The reading in the voltmeter V1. This is the reading in the voltmeter V1. So see, in V1 the reading will be addition of these, because in series voltage divides. So this will be V1 plus V2, that will be this. Okay. So voltage due to this resistor, voltage due to 100 ohm resistor. See, this is something like the resistor now, correct? This is the circuit. This is 100 ohm, this is 25 ohm, this is 25 ohm, and this is V2, right? And whole circuit we have this V1. We need to find V1. So this let's say VA. So V1 will be VA plus V2. V1 will be VA plus V2, correct? VA we have to find, but in VA we know the current is 0.9 ampere, right? So this is again using Ohm's law. Current is 0.9, resistance is 100, so that will be 90 volt. So VA is 90 volt. V2 we just calculated 11.25 volt. So V1 will be VA plus V2, that means 90 plus 11.25, that will be 111.25 volt. V1. Anyone has any doubt related to this? Yep. 101. It will be 101, right? Yeah, 101.25 volt. Very good, Hemant. Okay, let's move on. Okay, Aditi also said 11.25. Very good, Aditi. Great. Okay, so we just did, we added this 90 volt and this 11.25, which gives the 101.25. Okay, yes, there are still questions left. Jer, I'll call you Jer. Okay, questions, not much questions are left. 3 questions are left, but all are long answers, all are numericals, so be very careful. Okay, you focus on solving the questions. Okay, Hemant? Okay. 14's first part, explain why in household circuits only the fuse is connected in series. They are asking why in household circuits only the fuse is connected in series and all the appliances are connected in parallel. All the appliances are connected in parallel. Why? Do you have the answer to this question? Can anyone answer me? Can anyone give the answer, give the reason to this particular question? Okay, see, we all know that fuse is connected in series with the circuit, right? So why that is? Because we know in series, how you have to write? The fuse is connected in series because we know that in series, if one appliance breaks down, the whole circuit breaks down. The whole circuit breaks down, right? And that is what the function of fuse is. That is exactly what the fuse is used for, to protect the appliances. So in series, if there is lots of current, the fuse melts, breaks down, thus cutting the supply of current to the appliances and protecting them. Because if one wire is broke, then it does not affect other appliance. This is the answer to not the first part. Why the fuse is okay, this is the answer to the parallel. Fine. Okay, this is the answer to the fuse. Now, why the appliances are connected in parallel? Because they each needs individual current first. Why the appliances are connected in parallel? Appliance, because each needs individual current to function, right? Individual current to function, and they should get maximum or equal voltage from the source, and then the point that if one appliance breaks down, that will not affect the others, they will keep running like normal. Fuse are connected in series to attain the maximum resistance and break the circuit for protection. It works on the basis of Joule's law of heating. Very good. While other devices operate in different I. Very good, Jer. Great. Okay, next we have okay, this is the first part. First part is done. In a household circuit, an electric heater of power 1500 watt, a fan of power 500 watt are connected in parallel to a 220 volt supply. We have an electric heater. We have an electric heater of power 1500 watt. Its power is 1500 watt, and a fan. How will I make the fan? This is a fan, okay? They are connected in parallel, and this has power of 500 watt with a voltage supply of 220 volt. 220 volt. Done? What are they asking? They are asking a fuse rated for 10 ampere is connected to the circuit to protect it from excessive current. Now with it, a fuse is connected, and the limit of fuse is 10 ampere. This is a fuse, right? Calculate the total current drawn by the, okay, we need to find a fuse rated 10 ampere is connected to the circuit to protect the excessive current. First point is calculate the total current drawn by the heater and the fan. We need to calculate the total current drawn by heater plus fan. Okay, power is 2000 watt. Nobody asked power. Hemant. Power. Did they ask power? Let me see. They didn't. They asked calculate the total current drawn by the heater and the fan. Okay, so we have power, right? We have power of heater as 1500 watt, and we have power of fan as 500 watt, right? Both are getting the voltage as 220 volt. 220 volt. Fan is also getting the voltage as 220 volt. Right? We need to calculate the total current. That means IH and IF. Right? So, what is the formula of power which includes voltage and current? That will be V into I. Right? 1936 divided by 15 is the current drawn by them. Okay, let me know the complete answer. You will have to solve this in the boards, right? If this is the answer, you will have to solve the calculation by yourself in the boards. Okay? So, let me know the proper calculations here. So, I will be P divided by V, right? P is 1500 and this is 220. Same for this. P of fan divided by voltage. P is 500 divided by 22. If you calculate this, this will be something as, what will be the value of this? 150 divided by 22. Hi Khushi. Okay, Hemant is saying current as 9.09 ampere. Did you do the calculation by yourself, Hemant? Because in exams, you will have to do the calculation by yourself. Okay? Let me know. Okay, okay, 9.09. Okay, so if you do solve this, this will be simply 622 into 6 will be 12, right? It will be 132. Dekho, 22 into 6 if you do, that will be 12, that will be 132, right? So that's how you see if that is going on to that. Okay, then 6.132, that means 180 is left. Now 180 will be going by 8 and 1 8. So current in the heater will be 6.818. You can simply calculate it. Don't overthink it. Just write it down simply like this and do this. 22 into 6 will be 132, right? So 118 will be left. Now for what 18 will go, we'll need a point, that will be 180, and for 8 we'll have 176. We'll have 176, that will be again 4, right? Again we'll have a 0, then for 1 we'll have 22, correct? Very easy solution. Okay, so this will be 6.818 and I of fan. So this is fan will be 22 is 500 divided by 22. All of you have to do this calculation. Yeah, total power you can write 2000 watt, but no, see here the power is not being asked by anyone. So it is not necessary to calculate the power, okay? Everyone, any doubt? Oh, this is 0 volt, right? So this will be 500. This will simply be 50 divided by 22, and this can simply come out to be 2.224460. That will be 2.6 something, 2.3 or 2.2, but it is 2.2, around 2.2, okay? And then you add the total current, so that will be IH. Total current will be I of H plus I of fan. You can simply add 6.818 plus 2.2 we are getting, and the total will be simply 9. If you calculate this, you can just write the approximate answer, okay? Correct, everyone? 22.72 is what? Okay, next, determine whether the 10 ampere fuse is appropriate for this circuit or not, right? So this total is something as 2.27. This will be, I guess, 2.27. So you can just write the total, right? So this will be 9.0 something, 9.088. So you can write 9.09, right? Ampere. So if the total current passing from heater and fan is 9.09 and fuse is rated 10 ampere, so that is correct, right? Fuse will work appropriately. Very good, very good. Yes, it is appropriate. All the calculation, if you have any doubt in the calculation, okay? All the calculations, see, the calculation can be a little tricky, but you go through the very basic. Write it down exactly like this and you will solve it very, very easily. Done? Okay. Next question we have 13th. An electric heater consists of 3 similar heating elements A, B and C connected as shown in the figure. Each heating element is rated as 1.2 kilowatt. We have 1.2 kilowatt and we have the voltage as 240 volt. We have the voltage as 240 volt and has the constant resistance S1, S2, S3. All three has constant resistances S1, S2, S3. Okay. Then the circuit is connected to a 240 volt supply. Calculate the resistance of one heating element. Can you guys let me know what will be the resistance of heating element, any one heating element? 10 ampere, Aditi is saying. 10 ampere for what, Aditi? We are working on that, Hemant. There is a full team, don't worry about that. Only your friends didn't go. You tell me what will be the resistance of the heating element. Let's just see how we calculate it. See, for each resistance, the power is 1.2 kilowatt and the voltage is, each heating element is rated as 1.2 kilowatt and 240 volt. Right? So, I can directly use P equals to V square divided by R. Right? Oh, divide by R. Correct? Now, V square is 240. So, 240 into 240. Right? Now, power is 1.2 kilowatt. We have to convert it into watt first. Right? So, power is V square divided by R. This will be 1.2 into 10 raised to power 3 watt, right? V square is 240 into 240, correct? Divide by R. 24 square. What is the square of 24? You should know it by this. In 10th class, till 30, you should know that square. Okay? So, the square of 24 is, I am guessing, I am hoping it's 576, right? Okay, it is R. And 1.2 into 10 raised to power 3. So, 2 zeros will cancel out, right? And R will be 576 divided by 12, right? 1.2 into the 1 zero left, that is 12. Okay? So, the value of resistance will simply be, this will simply be 4, that will be 48. And how much will be left? 96, that is 8. 48 ohm. So, resistance is 48 ohm. Done? 48 ohm, Jay is saying. Very good. Very good, very good. Okay, next part we have, second part we need to see, calculate the current in each resistor only S1 and S3 are closed. We have to calculate the current in each resistor only when S1 and S3 is closed. See, this is opened, so no current will flow into S2, right? So, let's make the diagram again. What will be the diagram? This, see, this will be the diagram, right? This is my voltage source, that is 240 volt, right? And we have this resistance 1 and second resistance, and this is third resistance. Can I make this as like this? 48, 48, 48, right? Right? If S2 is not closed, this doesn't matter if it exists or not. So, we have two resistances in series and one in parallel. We need to find the current in each resistor. Now, see, in this resistor, in here, the current will go, I1 will go here, and let's say I2 will go here, right? But voltage, they are getting same voltage. In this whole circuit, A, B. In the AB circuit, the voltage is also 240 volt, right? And in this down circuit, in this below circuit, the voltage is again 240 volt, correct? So, to find I1, write it very properly. To find I1, R is what? R is 48 plus 48. Why? Because in series, resistance adds. We have the answer as 5 ampere. Very good. Let's see. The resistance is 48 plus 48. That will be 96 ohm. Right? So, V is 240 volt. So, what will be? We will be using Ohm's law. 240 equals to I. We have to find R is 96. So, I will be 240 divided by 96. Right? So the current will be what? 240 divided by 96. What do you have? Ma'am, do you have any? Focus on studies. I have so many degrees. I don't have any tattoo. Okay. Okay, A and C, we have current as 5 ampere. A and C. What is C? Okay, see, in this circuit now the current will be, this will be 2.5 ampere, right? The current will be 2.5 ampere in the first circuit. In this circuit, the current will be 2.5 ampere. Then, in this whole circuit, from A to B, the total resistance is 48, right? So, the voltage is 240 volt. So, the current will be 2.5 ampere, right? Now, in the third resistance, in this 48, let me name it 1, 2 and 3. In the third, R3 is what? R3 is 48 ohm, right? And voltage is 240 volt. So now in this V equals to IR, V is 240 equals to I, we have to find R is 48. So I is 240 divided by 48. What will you get if you divide 240 divided by 48? You will get 5 ampere in this case. So current is 5 ampere. So I2 is 5 ampere, I1 on the other hand is 2.5 ampere. Done? Jer, where did you do the calculation? 240 by 96 directly gives 2.5 ampere, no? Hi, the RCBN guy. Okay. Till here, if you have any doubt, let me know. If you have any doubt, let me know. Till here. Okay. Now they are asking, calculate the power dissipated across A when S1, S2 and S3 are closed. See, I'll just give you a hint. Okay. Yes, Art by Sri, I remember you. Hi, how are you? Okay, I'm giving you this question as not homework. Just here, I'm giving you a hint. What they are asking to calculate the power dissipated across A. So across A, we have to calculate the power when S2 and S3 and S1 all are closed. Now S2 is also closed. Remember, now S2 is also closed. So what will happen? What is the diagram? Let me see. This is the voltage source. Okay, these are two resistances. But now we have a different path as well. Now this is my diagram. 48. This is 240 volt, right? Now tell me, what is the power across A, B and this is C. What is the power dissipated across A? Can you answer it or not? Very important point you have to keep in mind. See, I have to go through two roads. One road is very bumpy. It is not being made with good quality material. I cannot do it. I cannot go there. Okay. Then other road is there which is very smooth, which is newly made. Which road will I choose? I will definitely choose the new road, right? The smooth one. So same is with the current as well. Here, if this is I1, right? We saw, and this is I2. Now, at this point, current has two paths. It can either go here or it can either go here. Which path will it choose? Will it choose the bumpy path? That means the path with the resistance, or will it choose a smooth path? Of course, ma'am, it will choose the smooth path, right? So instead of going here, instead of going through this path, current goes through this path. So this whole path cancels out. We can say this whole path cancels out, and now this is my circuit, right? There is saying 300 watt. Now this is my circuit, right? Now I just have to calculate the power dissipated across A. So across A, I have the resistance as 48 ohm. The resistance is 48 ohm, and the current is what? Current was 2.5 ampere, right? But here is a catch. You have to calculate the current again. Okay? You have to calculate the current again. Why? Because see, here first when current was going, this hole was giving it a resistance of 96 ohm. But now the resistance is only 48 ohm. So current will be different, right? So in here I will again have to calculate I1. That means power equals to V square divided by R, right? In previous case R was 96. Now R is only 48. Not V square by R. We have, where is that? We calculated power. Yes, see, we calculated power using V square by R. Now, look at this. The first power we had the power 1.2 kilowatt and we had the voltage. We had to calculate the current. So, we simply used the formula in which we had, see, in which we had the power, we had the voltage. The resistance we had to find, the resistance came out to be 48 ohm. Now, using that resistance, we find the current. To find the current, we simply used Ohm's law, right? Now, in here, we'll do the same. V equals to IR, but here the resistance is 48 ohm. Look carefully, here the resistance was 96 ohm, right? So, in here the resistance will be 48 ohm. We have to calculate. Voltage is given 240. So, I will be 240 divided by 48. That will be 5 ampere, right? I is 5 ampere. I'll put that I here. So, here I won't be 2.5. It is 5 ampere. So, V equals to, we have to find the power, right? Power equals to I square into R. I square is 5 square into 48. So, you can calculate 25 into 48. Let me know what is the answer of 25 into 48. Yes, 25 into 48 will be what? Simply do the calculation, very basic. 16, 200 into, this is 22 and this is 1200 watt. Very good, Jair. So, power is 1200 watt. If you have any doubt in any of this case, if you have any doubt in any of this question, let me know. Okay? Okay, so can we move on to the next question? Only one question is left, I'm thinking. Yes, this is the last question. Read it very, very carefully. Okay? What is the last question? Two resistors R1 and R2 are given, that is 6 ohm and 12 ohm. Okay? So, R1 is given as 6 ohm and R2 is given as 12 ohm. Right? Are connected in parallel. Now, they are connected in parallel. Correct? To a 24 volt battery. We are also given with the 24 volt battery. The circuit operates for 5 minutes. The time is 5 minutes. Okay? Calculate the heat generated. We have to find the heat generated in both resistors. And second, if each resistor has a power rating of 100 watt, determine whether it is safe to use these resistors in the circuit. You are not allowed to do any more chit chat here, so it's fine. Follow the question, read the question. Calculate the total heat generated in both resistors. We have to calculate H1. Now, what is the formula of H1? That is related to voltage as well. So, that will be V square into T divided by R, right? That is V square T divided by R. So, H1, let us calculate H1, right? H1 will be V square T divided by R1, right? Now, the connection is parallel, so voltage will be same, so V will be same, right? So, V is 24 volt, R1 is 6 ohm. Let's calculate. V square is 24 volt, so that is 24 into 24. Time is in minutes, so that will be divided by 60. Okay, so 5 divided by 60 into resistance is given as 6 ohm. Correct? So I can just use this. 6 4 is 20. This will also be 10. It is 4. 4 into 5 will be 20 and 20 into 4 divided by 10, right? This cancels out. So 4 into 2 is simply 8. 8 joule will be the heat dissipated by the first resistor. Done? 240 volt and 480 joule. 240 joule? Did we do any mistake? Did you do any mistake? See, R1 is 6 ohm, R2 is 12 ohm, battery is 24, the circuit operates for 5 minutes. Jer, how are you getting 240 joules? V square T by R is what you are using, right? Then T is 5 minutes. So if you convert it into, okay, my bad. I converted into hours. I have to convert it into second. Wait. That is on me. 24 into 24, 5. 5 into 60. Right. So R1 was what? R1 was 6 ohm. Correct. So this cancels out and then we are left with this. You took minutes, so we both did wrong. Okay? You have to take seconds. Not the I took hour, you took minutes. You have to do seconds. Okay? So 5 minutes into 60 seconds. Okay? So this will be 576 into 50. That will be 0 and 0, 3. We have 35, 8, 3. We have 33800 joules. This will be the heat generated. Check your answer now. Okay. The same you have to do with the another resistor. Same you have to do with the another resistor. Another resistor is just 12. So you just have to change the value of resistor in this case. Instead of 6, it will be 12. That means 24 into 24 into 5 into 60 divided by, this will be 12 now, right? So 12, 2 will be 24, right? So you can simply calculate 2 into 24 is 48, 5 into 60 will be 30, right? So 8, 3 is 32, 24. 24 to 12. So this will be the heat dissipated in the second resistor, right? Any doubt till here? Till here, if you have any doubt. Done? Okay, that was the last question, everyone. We are done with all the sample paper. Oh, one question is left. If each resistor has a power rating of 100 watt, determine whether it is safe to use these resistors in the circuit. See, if each resistor has a power of R1 and R2 has a power of 100 watt, right? 100 watt. So, will it be okay to use these resistors in the circuit or not? If each resistor has a power rating of 100 watt, determine whether it is safe to use these resistors in the circuit. Do you know the answer to this question? What do you have to do for this question? 300. What is 300 gaming? Let me know if you know the answer to this particular question. Okay, you simply have to calculate the current. See, you have two resistances and you have power. So what you will do, you will calculate the current. R1 is 6 ohm, R2 is 12 ohm, right? So P1 each is 100 watt. So P1 is 100 watt, R1 is 6 ohm. So from here, can you calculate current? Can you calculate the current, right? Where how? P equals to I square into R. That is, this question I am giving it to you. Yes, I am telling Jar, I am giving this question to you, but you have to do the calculations, okay? See, so you calculated power from here. Can you calculate I1? You will calculate I1 from here, right? Then same you have to do with the second question. P2 is also 100 watt. And we have R2 was 12 ohm. By using again the formula, P2 equals to I square R2, right? From here, can you calculate I2 as well? Can you calculate I2 as well? And then you'll calculate the total current. The total current will be, since it's in a parallel, so total current will add up, right? The total current will add up, and then you will compare with the actual current that is flowing in the circuit. If the current that they are using is less than the actual current flowing in the circuit, then it will be fine to use these two resistors in a single circuit. Otherwise, it won't be. Fine? Everyone? Anyone has any doubt regarding this, all the chapters? If you have any doubt regarding any of the question, and if you have any doubt in physics in general, let me know. Okay? How to calculate the normal current? Normal current, see, you are given 24 volt battery, right? 24 volt battery and two resistors are connected in parallel. So RP, 1 by RP will be what? 1 by R1 plus 1 by R2, that will be 1 by 6 plus 1 by 12. Easy, this is very easy. 2 plus 1, this will be 3 by 12. So RP will be 4 ohm, right? So you have voltage and you have resistance. Can you calculate the current? Now if that current, yeah, see, okay, Jair, listen. You have these two circuits. You are given with the voltage. Now from the voltage, you can calculate the effective resistance of this circuit. We did it, right? So RP is 4 ohm and voltage is 24 volt. If I use V equals to IR, Ohm's law from this, I will be what? V is 24 volt and R will be in the division 4. So I is 6 ampere, right? I is 6 ampere, that is in the circuit. Equivalent current, total current in the circuit, right? Now what I did, I found the total both of those resistors are using a power of 100 watt. Now from there I found out what exactly these resistors, how much current these resistors are using. Okay, how much current these two resistors are using individually. Then I'll add those. If those current is less than the total current, then that will be fine. If the current used by two resistors will be less than the total current that we calculated, same 6 ampere. If it is less than 6 ampere, then it is fine. Then it is safe to use those two resistors. If it's not, then it's not. Okay? This is a physics class. Ejwani poo. Okay? Okay, Jair? Good? We are done with all the questions of the sample paper. let me know, solve it, and let me know in the comments if the current is less, if it is safe to solve, if it is safe to keep those resistors in the circuit or not. Okay, great Jar. That is it for this live. I had a great time. We solved so many questions. These all questions are very important. If you have any doubt, go back, watch the video again, comment down, come into the next live, ask the doubts again. Okay, we are here with you, standing strong and preparing strong for our boards. Okay, that is it for this live. I'll see you in the next one. Okay, bye.